So welcome to our talk today. The topic of our talk is Venmo's experiences with Aurora failovers using ProxySQL. Let me kick things off by introducing ourselves. I'm Yashada. I'm an engineering manager at Venmo. I have around 10 years of experience working with various flavors of relational databases. At Venmo, I'm part of a team of talented database engineers who support our Venmo platform. And I have been at Percona Live before. I'm glad to be back doing this in person. It's nice to see you all again. And I share random database thoughts at my blog, DB Geek Girl, on WordPress. With me here today is my colleague Kushal. He is a tech lead at the Venmo databases team. He has 8+ years of experience working with various relational and NoSQL databases. He had a talk yesterday on scaling Venmo databases that some of you might have attended. Kushal has also been at Percona Live before in the virtual era, so that was a fun experience for him. So a little bit about Venmo. We are a rapidly growing peer-to-peer payments app. One of our attractive points to our users is our unparalleled social feed, which drives engagement within the community. We are growing fast. We have seen about like a 44% increase in our payment volume in 2021 alone. In addition to our peer-to-peer capabilities, we are also building products and services to meet the evolving financial needs of our customers. Some of these services are instant transfer, credit cards, business profile that help us enable our customers further. We have also launched options to pay for businesses online using Pay with Venmo, as well as like in-store QR codes for payments. So from being a P2P app, we have a journey in which we are diversifying into other stuff also as the consumer landscape changes. So our talk for today, let me go briefly over what our agenda is. We would go over the architecture that we have for our databases and application. Then we will dive a little bit into our infrastructure as code implementation for ProxySQL that helps us deal with things better. We will talk a little bit about why we chose ProxySQL for our planned failover. After that, we will dive in a little bit to our recipes for a painless planned failover. We will also talk about finer points of a failover using a framework of 3 Ps of a successful failover, focusing on people, process, and product. We will also talk about an interesting use case where we used ProxySQL other than plain vanilla failovers. And we will wrap it up all by learnings and visions for the future. So with that said, let me hand it over to Kushal to talk about our architecture.
Yeah, as you can see in our architecture, like the application which is shown over here as the service kind of uses CNAMEs for into that config to connect to our databases. Over here, as you can see, we have RDS Proxy in between the databases and application. The reason why kind of we use RDS Proxy was more something that we kind of discussed more into our yesterday's talk about scaling Venmo, and all the motivation behind why we have to introduce RDS Proxy in our architecture. We do have like one of our clusters is still a monolith, and we are working on moving that into a microservice-based architecture, and that's where we were like kind of hitting connection limit. And the reason why we selected RDS Proxy, we'll kind of briefly talk about that before going into the failover specific use of ProxySQL for failover. So we kind of have 2 options in terms of using proxy for connection multiplexing and handling connections, managing connections to deal with a monolith kind of infrastructure. One of them, which is widely used in the industry, is ProxySQL, and being on AWS, we also have another option about using RDS Proxy for doing connection multiplexing. As you guys know, like ProxySQL is an open source which has been widely used and have a good support throughout the community, as well as it supports various different features like routing traffic based on different rules that you can set up within ProxySQL. And we currently didn't have any such requirements, but something to keep in mind in case like you run into some use cases in future, and we can leverage those. We'll talk in more detail throughout the talk about how we use ProxySQL for intercluster failover and do a planned maintenance using that. The reason why we kind of didn't use ProxySQL for day-to-day use and not using it for connection multiplexing was we had to build some other automation around ProxySQL which we were not fully ready with while we wanted to implement proxy for connection multiplexing within a short period of time. We still have some challenges around managing the health check and the frequency how we run health check to use that more seamlessly, and also adding and removing the node from the proxy cluster seamlessly, and that's why we are still not using it in production, but at some point we'll try to get there and see if we want to use the one solution for everything instead of using just for a failover basis. RDS Proxy is a managed service from AWS. It kind of helps in terms of integrating with Secrets Manager. Being managed service, there is not that much of operational overhead. Most of the things in terms of patching and maintenance is handled by AWS, being a managed service. Though one of the requirement that we had about handling custom endpoints is kind of not currently supported by RDS Proxy, and we kind of had a workaround for now, but that's something it will be good if it be supported in future. A bit more on RDS Proxy. When you spin up an RDS Proxy service, you don't have to configure any most of the things. Those are kind of configured based on the Aurora cluster that you guys are using. Based on the instance type they are using on Aurora cluster, it will spin up the number of proxy nodes based on that config on its own, and AWS will decide number of proxy nodes to run in the backend. Even in terms of configs that you may have to provide to the proxy layer, are all those imported from your Aurora cluster itself. There's a couple of parameters that you can tweak. One of them is max connection percentage, which helps to decide how many connections you want to have RDS Proxy open to database, and that kind of helps us in terms of managing connection, going to our database and handle the connections. One other advantage of using proxy in between your database and application is that it can help reduce the failover time if you are doing a failover within the cluster, within the Aurora cluster in our case. As soon as proxy detects that the Aurora cluster is not the node on the Aurora cluster is not available, it will stop sending more traffic to the cluster and queue things at the proxy layer. And as soon as it detects that node is available, and it will start continue sending traffic. You may see some latency on your application end during this window, but you will not see the same number of errors you may see without using proxy. So there are certain things to keep in mind in terms of different timeouts that you have set up, which will kind of depend how much percentage of time you are saving or how much percentage of errors you are saving in terms of failover. If your application timeouts are very aggressive and those are kind of less than the timeout Aurora instance takes to restart, you are going to see those times out in your application and will see some of those errors. Similarly, if you have set up the parameter borrow latency timeout on RDS Proxy, and if those are also set to a lower value than the instance restart, then you are going to see some of the timeout errors because of that. So you kind of have to balance out in terms of setting those timeouts, and depending on that you can see less number of errors or more number of errors when the failover happens and while you are using RDS Proxy. Now let's talk about where ProxySQL comes in picture and how we leverage that, for which use cases we leverage that into our infrastructure. So some of the initiatives where we use ProxySQL for failover were upgrading Aurora from Aurora compatible 5.6 to 5.7, as well as if you have to enable encryption at rest on Aurora, you cannot do in place. You will have to create a new cluster where you enable encryption at rest and have to failover to that cluster. The other use cases where we kind of make use of ProxySQL was to breaking out some of the data from monolith, which is our big 30 terabyte cluster, into a smaller databases, which kind of helps going into microservice based architecture. You can use this for many and number of use cases where things like altering a big table, which you don't prefer to do it on the live cluster and wanted to do by setting up a new cluster and make changes over there and then fail over to that cluster. All those use cases kind of fit well, and you can use that ProxySQL for doing so and failover by using ProxySQL. Let's look at our architecture, how things look when we introduce ProxySQL in our infrastructure. We kind of use infrastructure as code for setting up infrastructure for ProxySQL, and we'll talk more about that in detail in coming slides. While we introduce ProxySQL, we basically just update the CNAME that we are pointing to RDS Proxy before. We just pointed to load balancer endpoint in this case, which kind of points to ProxySQL, which is within an auto-scaling group. And then ProxySQL points to respective clusters based on the host groups that we have set up on the ProxySQL config. To start with, it will point to the active cluster, and the new cluster, which is our target cluster for failover, won't be getting any traffic based on the host group config that we have on the node. Now let's talk about what we use in terms of setting up the infrastructure for ProxySQL. We use CloudFormation to spin up the infrastructure, the resources within AWS, basically the EC2 instance, auto-scaling group, load balancer, and part of spinning up the EC2 instance, the user data kind of triggers the Ansible playbook, which configures the ProxySQL and make it ready to be ready for failover. Part of the Ansible script, it installs all the packages, it gets all the config that we need to apply them, that is the metadata. We kind of store it in Secret Manager, which uses that using the config script to configure the ProxySQL and be ready for with the required clusters. And Ansible also configures data log, which will be used for monitoring and other purposes. We'll talk more about the config that we have, the metadata that we have in the Secret Manager, and how it has been used by the config script in detail in coming slides. What CloudFormation kind of installs when we spin up the infrastructure using that. So it basically sets up all the instances within the auto-scaling group. It also sets up the load balancer and the target group config along with that. And as I mentioned, like the secret config will be fetched using the user data, which will eventually be like call the Ansible script and fetch all the config and set up ProxySQL. Now let's talk about how things look like in the metadata config that we have within Secret Manager. So as you can see, like it will have details about the credentials that we will be using to configure ProxySQL, the worker threads that we are allocating for the writers, as well as the instances that will be used for replica, that is will be handling the client connection, that it will handle a database connection to the client request, as well as it will have the cluster nodes, the instances of the active cluster, which we will be assigning like the host group 200 and the number of connections that we want to provide to open from that particular on that particular instance from proxy. And then we have other set of the cluster, which is cluster B, which we currently provide the host group of 400 and the respective connections. Then we set up, provide information about all the users and allocate those users into respective host groups. And all this information along with the other parameters that we need to provide the ProxySQL for all the MySQL parameters like max allowed package character sets or anything else that you want to set up, you can provide in this metadata config. We talk about using Ansible for setting up, using this config and setting up the ProxySQL, but Ansible usually runs just one time, but you maybe have to update the config and apply additional changes to the ProxySQL config. So how that thing is handled. So we use AWS State Manager for that, which runs on a periodic time period. So it kind of fetches the config from secret manager, compares the config with what's currently running. If it finds that there is a difference in the config, then it will apply the changes. Otherwise, it will just won't make any difference over there. Now let's see how we go and plan the failover and execute the steps at the time of failover. Just a quick refresher about how things look like before we go into the planned failover. Like we are currently using RDS Proxy, and we will be introducing ProxySQL during the maintenance window. As I mentioned earlier, like we'll be updating CNAME and we'll start introducing ProxySQL. We'll make sure like all the connections are switched to ProxySQL and not using RDS Proxy anymore. We can either time it like to make this change right before a deployment, or if we still see some connection, if we are not able to plan it accordingly, then we can selectively restart some application to make sure connections are rotated and moved to ProxySQL. Currently, the ProxySQL, depending on the host crumble, will be pointing to the active Aurora cluster. Now let's see how things goes when we do the actual failover. This is kind of the recipe of painless failover when we kind of go in terms of running the script for failover and triggering the failover. So cluster A is with host group of 100 and 200. So 100 will be set up for the writer instance on the cluster, and 200 will be used for all the replicas. Cluster B, which is kind of the new cluster, the target cluster, it will have the config of 400, and 300 will be set for the writer instance of that cluster. To start with, we'll do some initial validation just to make sure everything is set up properly and configured properly. We also validate that there is no replication lag between the current primary cluster and the target cluster. We first of all trigger the failover script, which is written in Python in a dry run mode. In the dry run mode, it will kind of do the same check that are also mentioned in the next step, that both the clusters are read-only off and there is no replication lag. This is because we wanted to make sure that when we actually do the failover, we don't failover while the target cluster is still set to read-only on, and we don't run into any errors because of that. So we validated that if we don't find, and once after those checks are done, it will also show you all the detailed steps that it's going to do when we actually trigger the failover, about the switching of host groups that will be done and how it will exactly switch the connections from the current active cluster to the target cluster. If things looks good while we'll do the dry run, we go to the next step of doing the actual failover. So it will check the same things that it did during the dry run, but in this case, it will wait. It will not do the failover right away once we trigger the script. It will wait for us to update the current active cluster to read-only on. And it will keep on checking if the cluster is read-only on or not. As soon as we make that cluster read-only on and it detects that the config has been updated, it will trigger the failover. In this case, the first step it will do is set the cluster A to online soft. So it will stop sending any new traffic to the current cluster. And it will continue to drain connections from that cluster. And if we have set up a time of 10 seconds, if it doesn't be able to drain all the connections in 10 seconds, then we just set it to offline hard, just to make sure we are closing all the connections and making sure there is nothing connecting to cluster A. After that, we'll just swap the host groups. So now cluster B will become with a host group of 200 and cluster A will become host group of 400. And that's where our users are being set up to connect to. Just to make sure we are ready for any rollback if required, we will again set the cluster A to online. So if we need to roll back, we are not taken that the cluster A is still in offline hard state and we don't run into issue. So we change it again back to online. And at the end, the script will do some final checks to make sure things are set up correctly, and we'll just provide details on what change happened part of the failover so that we can just validate one more time. And that's how the failover will be done, and will be now routing traffic to the new cluster. And once the failover is done, we'll again switch back to start using RDS Proxy and update the CNAME, and the next deploy will switch all the connections back to RDS Proxy. We'll hand over to Yashada to talk about the framework of 3 Ps that we use for planning the failover.
Okay, so far we heard about our tech stack and architecture around our failovers. I just want to bring a thing up here that doing a failover is a team sport. Doesn't happen in isolation with the database team alone. So we have this framework for planning a painless failover that we have concentrated around people, process, and product. So let me talk about people first. Whenever we are doing a failover, it is really important to identify who are the different stakeholders of your failover. These might be your application teams, your SRE teams that you need to be on standby. They might be business users that you need to keep in loop. So it's important to identify these stakeholders for all your activities, for planning, for execution, for post-execution activities. When you're planning a failover, it is important to identify and document who will execute what, who is your responsible and accountable person for executing those steps. Things can go wrong during a failover, or unexpected things can happen. So it is important to have go, no-go decision makers for each flow point, so that when unexpected things do happen, you're not left stranded thinking, who makes this decision now? It's also important to kind of figure out from the beginning who should be kept informed till what level of details for each of your steps. Maybe there's a certain audience you just want to communicate end results with, but there's a certain audience that you want to keep involved for every step in your execution. So it's important to vet that from the starting. For a successful failover, whenever you start planning, it's important to communicate early and with as much concrete data as possible. What this results in is building confidence in what you do so that people can back you for a successful failover. So that's the people element of it. Let's talk a little bit about the product element of it. What we often see, especially in the DBA world, is that we do all our testing around our databases, right? So if we see that connections to the database came in fine, the database comes up again, we say that, okay, our failover testing is successful. But it is important for all the testing that you do your monitoring holistically and end-to-end. You look at how your products react, how your APIs react, not just how your database reacts, because your total downtime is your application downtime, not just your database downtime. To that end, it is important to identify what signals is your product sensitive to. Some of the products are more sensitive to latency. Some are more susceptible to a drop in throughput. So you want to figure out what those signals are. You want to monitor those. And you also want to know what are the acceptable and unacceptable levels of those signals, so that you can keep an eye on them and they factor into your no-go decision making if you have to take one. Whenever you're communicating, it is important to communicate the benefits and risks, not just in terms of technology, but also in terms of product, because that gets you that buy-in, that what is the product getting from this maintenance or failover. So that's about product. Let's step into the bigger part of this all, the process. Before a failover, it is important to do extensive non-production testing. And this testing has to be as if you were doing a production failover. Like I said before, it's important to gather holistic data during your non-production testing, not just what your database does. If you have the results of this testing well documented and you communicate this early, you build this confidence in people that, okay, this team knows what they're doing. and you're more likely to receive support and backing when things don't go according to plan. An important part of a failover is to create a runbook. So let's talk a little bit about what are the best practices for a failover runbook. One of the things is that we like our runbooks to be as exact and precise as possible. So we include exact times of failover, meeting bridges, Slack channels, everything that you need about a failover should be in there. It's important to document teams participating in failovers with point of contacts, backup, escalation matrix, so that you have one document to go to when you are doing your failover. We also document the infrastructure that is impacted by failovers and the observability links for those infrastructure. We enumerate each task with the exact endpoint, start and end times, and the person executing it. It's also a good idea to have a status column in the runbook that the person executing it can update, just so that as you are going through, people can look at the same runbook and know where exactly we are. If you have a maintenance that's going to run like an hour, 2 hours, and you want multiple teams to be present, it's a good idea to call out what teams need to be present at what part so that you don't have everybody held up for the whole duration. If you are going to have downtime, it's very important to quantify how much that downtime is going to be and clearly call out at what step it's going to be. It's also important to have a post-failover sanity check and a definition of done. And very importantly, if things don't go according to plan, it's important to document a well-vetted rollback plan. So we spend a lot of time creating this runbook because this is what gives us the success during a failover. It's also a good idea to share the runbook in advance, at least a week or so that different stakeholders can review it and give you their feedback. So what happens in the process during a failover? Since you put in all the legwork, during the failover, you just follow the runbook because a production failover is not a time to experiment. A good idea is to have the person executing the steps only update the status of the step or call out the success of the step. For all ad hoc communications, it's a good idea to designate another person who fields questions or can go into details if required. This creates sort of like less interrupts for the person who's actually executing the steps. It's a good idea to rope in help from either your team or other teams to keep an eye on different observability dashboards while you're doing a failover, so that if something goes haywire, they can call out that signal. If things are not going according to the plan, refer to the no-go decision makers and the flow points that you have documented in your run up to the failover. And at last, if there is a no-go or if things don't go according to plan, don't be afraid to roll back. You would rather have a clean failover than a botched up attempt where you're trying to reconciliate things after. So after a failover, run the documented sanity checks, the definition of done. It is important to allow a bake-in period. If you have like a standby cluster, think about what your bake-in period needs to be, maybe a week, a fortnight, just keep it running. Because your rollback step might not happen, say like 30 minutes from your failover, but you might realize 2 days later something has happened and you need to go back. So figure out what that bake-in period is, stick to that. And thank everyone who pitched in for your failover. Like I said, it's a team sport. There are a lot of people involved. Designate a person to keep an eye on how things are going after your failover too. Because like I said, some issues can surface later, not immediately after a failover. I will just talk about a little bit of an issue that we ran during our failover, just to kind of highlight how planning for a failover or doing a failover is an unexpected things can happen. So like you see, we started seeing this thing in our logs, and our connections would just terminate. And we would see this error called received malformed packet. And we had no idea why this was happening. When we dug into stuff, we kind of figured out that this was due to a MySQL bug, where if a client connects to a MySQL server specifying a collation, and the server does not know the collation, the server allows the connection to go through. But when ProxySQL is running change user, then it returns this malformed packet error. And I'm not very sure, but I think Rene reported this bug for MySQL. So we were running on 2.1, I think, at that time, and we ran into this. And for remediating this, we thought we would upgrade. We did the upgrade, and the upgrade alone didn't solve it for us. What solved it for us was fixing, or rather, setting these two variables, MySQL enable kind deprecate EOF and MySQL enable server deprecate EOF as false. Once we did the upgrade, set those variables, and restarted ProxySQL, we were able to do things smoothly. So, I mean, this example is just to bring up that even though you might do everything by book, by plan, you might sometimes run into issues that you don't expect, and you might have to remediate those. So the non-production testing really helps with that. So to take things further, I will hand it over to Kushal to talk about an interesting use case that we did using ProxySQL.
We are in journey of converting from monolith into microservice-based architecture, and that's kind of important that at the same time, while we are having the separation on the application side, we are also separating out the data at the database layer and moving into smaller databases. And we'll talk about how we make use of ProxySQL in this scenario. First of all, as we mentioned, right, we need, for any failover, we need to create a target cluster and then failover to that cluster. And that's how we kind of use ProxySQL for doing failover. But in this case, as we are only migrating certain percentage of data or certain specific number of tables for the microservice, we only need to care about those tables and not everything else. There are different ways that we can achieve this, like in MySQL, where we can just set up replication filter, and we can achieve this very easily. And while as we are using Aurora MySQL, we don't have option to set up replication filtering. Either we can use DMS to copy the data for specific tables that we use, and then just dump the schema for the remaining tables so that we can use replication, or we can just continue to use DMS to replicate the data over. The other challenge that comes up is we need to specifically measure the replication lag, and we don't get exact replication lag if we are using DMS when we are doing failover. Either we need to introduce PT heartbeat or something like that. We can help measure the exit lag, and we can kind of overcome that challenge. Other option is just to use MySQL dump or MyDumper and load the data for the specific required tables and just copy over the schema for other tables and convert those to black hole engine and continue with that route. But with that, the time that you need to copy the data over can vary depending on the size of the tables that you are planning to migrate over to the new cluster. So the route that we kind of went up with is following the same route. We have like take a snapshot, create a new cluster, but after creating that cluster, we kind of convert all the tables that we don't need as a black hole engine. So we basically like truncate the table and convert those to black hole engine. While before converting tables to black hole engine, you need to make sure if any of those tables that needs to be converted to black hole engine have partitions, you kind of make those to a regular schema, and then you can go ahead with converting to black hole engine. And then eventually you can just set up replication between the two cluster, and you can even do circular replication, use MySQL replication for both forward and backward replication, and continue with the remaining failover plan as we are just doing for the regular cluster. Let's look at how things look when we introduce a new microservice into our infrastructure. So the new microservice will have its own service, which kind of uses its own users for MySQL, as well as different CNAMEs apart from using, and not these CNAMEs that we were using for the monolith application. So it has its own separation in terms of MySQL user as well as the CNAMEs that it is using to connect to the database. And they will use RDS Proxy and continue to connect to database using that. During the maintenance period, we'll introduce ProxySQL, And over here, instead of pointing everything to ProxySQL, we selectively only point the microservice that we want to cut over to the new cluster and not all the traffic, as we are not making any change to the other services that is being using the current active Aurora cluster. So if you remember that while doing the failover, we need to set up the active cluster to read only on, and then how the failover triggers in the ProxySQL failover script that we have. For that, and to avoid that, because we are still using it for other traffic, we cannot set to read only on. So for that, we kind of just created a table inside the active cluster, which can be act as just one particular row, which act as an failover flag. That will trigger the failover script, will continue from there on and do the failover just for that microservice. So again, like cluster A and cluster B are set up with different host groups, and the users for the microservice are only been added to the respective host group, in this case, instead of all the users. We do the validation, trigger the failover script. In this case, instead of looking for cluster A to be read only on, it will only look for that field in the table, that if that field is changed to read only on or not. And as soon as it detects that, it will move on and convert the host group to read only offline soft, and then will continue on and do offline hard. In this case, like as we are only using ProxySQL for that one particular microservice connections, so it's not going to train all the connections, only will train the connections that are coming from that particular microservice. And then it will continue to change the cluster A back to online, so that if we have to roll back, we still can continue with that. And we'll swap the host groups and we'll start sending traffic to the new cluster for that particular microservice. This is how things will look like post failover. Instead of sending traffic from ProxySQL to the active cluster, it will be sending it to the new cluster which is being used by microservices itself. So we will have suppression in those terms. While doing the suppression, we do have some additional safety measures we kind of took to make sure we are not writing to the cluster, because we never set that cluster to read only on, which was kind of a safety measure in the previous case. So we kind of go ahead and like lock the user on the active cluster, as well as increment the auto increment on the new cluster, just to have the safety measure in case there is some data which hasn't replicated fully, and we need to keep that auto increment some room just to have the extra safety measure. But ideally, it's not kind of something we should need to have 100%, but just to have extra safer side, we increment the auto increment just to make sure if there is any replication lag, we don't run into auto increment ID conflicts. And in the end, we will just update the new microservice to, instead of using ProxySQL, we'll directly kind of connect to the cluster itself. As in the microservice world, we kind of don't have challenges about managing connections or anything else that we need to use any proxy layer in between. That kind of helps in terms of reducing the cost in terms of latency as well as the infrastructure cost. So in microservice world, we kind of just directly connect to the cluster itself and not use proxy altogether. We'll hand over to Yashada to talk about some key takeaways that we have by going through this process.
So one of the things that we learned during our entire failover process and planning is that if you're going to do something often, automate it. The reason we are able to do all these failovers painlessly is because our failover script is automated. So we're not copy pasting commands and running those. We are just changing the flag to trigger our failover. So if you are going to be doing something often, don't be afraid to automate. Sometimes we have this thinking where we think, okay, what if I write this automation script and things go wrong? You won't know until you test it. and if things will go wrong, that's your opportunity to go ahead and fix it. But unless you automate and run your scripts, you won't know what will go wrong. So there is value in automation, specifically for things you're going to do very often, even if it's like once a month or once a quarter, right? There's value in automating those. The other thing that we learned is that it's important to do non-production testing. And the lessons that you learn from the non-production testing is what you take away to your production failovers. So nothing beats the practical experience of doing failover testing in your non-production environments. As well as never underestimate the power of good documentation. Like I said before, if you have a good run book that you wet through your non-production testing, when you actually go to your production failover, there is less probability of things going wrong. Things might still go wrong, but at least you would have most of the bases covered. So these are our lessons learned from the failovers that we did so far in our setup. Just thinking towards the future, what we ideally want to do is, with the help of this infrastructure as code that we have and our failover script, get to a point where failovers can be self-serve, where our application teams can say that, okay, for my microservice, I need to do a failover. Give me a trigger to do it. It could be a UI, it could be a command, and they themselves can trigger the failover, and the DBA can just be on the standby and come in if there are issues. But ideally, that would be the thing, where we can have this self-serve capability for failovers in our system. Hopefully, we can reach there with steps we are taking. But yeah, that seems to be like an interesting end goal of where we want to be. So that's our lessons learned and vision for the future. And plug for our team here. We are a team of awesome engineers. Come work with us. We have a rec open. The link's up there. You can either go ahead and apply, or you can even reach out to us. We are fun to work with. So yeah, that's it from us. I'll open it up for questions.
When you're upgrading a version of MySQL, what's your rollback plan? Do you replicate back?
We do replicate back. And
Usually works?
well, whenever we are upgrading, at least till we have the bacon period, we make sure not to use any features that are not backward compatible. So that's one thing that we have to do.
How long takes the failover process?
I think it takes a minute or less than a minute.
To complete the failover, so downtime is less than 5 minutes, 5 seconds. So only 5 seconds, that's when like the instance goes to offline soft and offline hard, and update the ProxySQL config by swapping those groups. It usually is done in 5 to 6 seconds. And in worst case, where there are some long running queries, we have a timer to set offline hard in 10 seconds. So max will be 10 to 15 seconds in the worst case scenario.
I think so the thing with our failover script, if I can go back to it. Yeah, this one. So the thing that we do is that we have read-only off on both the places, and then we do read-only on one. So there isn't an extended time where both your instances or clusters are read-only on, where you will see the queries getting rejected or a downtime. So that is why the downtime time is really less, because it's just the script flipping.
Have you used the failover procedure to canary switch? Like, I just want to switch my reads.
Not yet.
We haven't tested that yet.
Come back when you do.
Yeah. So our friend Jervin here wrote a lot of these scripts. I think they should be there in the Percona thing, but we'll have it on our slide shares. Yeah.
Any other questions?
All right. we'll hang around for like 5-10 minutes if anybody wants to talk. Right, cool.